to Rasayanika. Hi, this is Shatarupa and welcome back to our today's session, live session that is on CSIR Net Rapid Revision Rounds. Okay, so hope you all are doing well. Okay, so before starting today's session, I would want to say that am I audible to everyone? Just type to confirm me, am I audible or not? Hamad Kalkar, hi ma'am. Hi Hamad. Good evening, Hamad. Mahesh Joshi, good evening, ma'am. Good evening to you also, Mahesh. Rajrupa, yes, ma'am. Okay, fine. Okay, so I am audible to everyone, right? Okay, so yesterday I think we had a very good live session yesterday, and you all have enjoyed that, right? You all have enjoyed, right? So today is our third live session, and this is on our rapid revision round or on CSIR Net. Okay. So before starting our session, I would like to say I think I would like to one thing to all of you that yesterday some of you asked me the important topics on chemistry actually, which are very relevant for our upcoming CSIR Net examination, right? Okay, so I would like to say some important topics which you can refer or you can read very carefully. At first, start with physical chemistry, okay? So, for physical chemistry, you need to start with thermodynamics and you need to cover it very well, okay? Thermodynamics, quantum mechanics, that is quantum chemistry for you all, and also spectroscopy, this is molecular spectroscopy. Yeah, these all are very important part because a great marks, huge of marks that all every year CSIR used to set that type of question from these topics actually. So yeah, apart from this, some independent like topics from physical chemistry you must prepare for those are basically the solid state chemistry, the surface chemistry, and kinetic theory of gas. These all are mainly the important part. Okay, so these are from actually physical chemistry. Group theory also another important part. And let's move to our next part, that is inorganic. So among inorganic, you need to prepare the basically the topics mainly very important for you. Those are coordination chemistry, bioinorganic, organometallic. These three topics are very important for CSIR Net or GATE, that kind of all India of examination. Okay, you must prepare these topics. And apart from this, in inorganic, I would like to say the reaction mechanism, there is also something, okay, some questions also come from that part. And also your bonding, VSEPR theory, molecular orbital theory, these all are very important part, okay? Apart from this, inorganic, the group chemistry is very important for you. Okay, so let's move to our organic part. So in organic part, I would like to say the reaction mechanism, the stereochemistry, these two parts are very important. And obviously the pericyclic reaction. Okay, all the sigma-tropic reaction, all the everything like in the pericyclic reaction, they took actually very huge marks in the question paper every year. And also photochemistry, there also it's also included in this. So this all the some few important topics which you must read actually for your or prepare yourself for your CSIR Net examination. Okay, so let's start with our today's session with our first question. Okay, so I'm moving the slide. Okay, so this is our first question, and the question is, a quantum mechanical particle of mass m free to rotate on the surface of a sphere of radius r is in the state with energy 10 h cut square divided by mr square. The degeneracy of this state is, and which is the correct option? So you need to find the degeneracy of the state. Okay, so anyone from you would like to answer this question? Just type the correct option in the comment box so that it will be visible to me. Mohammad Kalibullah, chemical kinetics, electrochemistry. Spectrothermodynamics, quantum mechanics, and group theory. These all are mainly important part, but you have to cover all the topic, Mohammed. If you want to crack really the CSIR net, so you need to cover all the topics. Okay, most of that 90% you have to cover. But these are the very important part because a huge marks are allotted from those parts actually. Okay. Okay, so first answer came, that's Mohammed Kalka Abdullah, it's 10. 10s. Okay, option B. Mohammed, you have answered 10, that is option B. Rajrupa also answered the option B. Okay, anyone else would like to answer this question? Just try yourself, try by yourself. Okay, another answer we have Papri, that is option C. Okay, so we have a lot of answers and most of them you have given the option B, right? Okay, so basically I am going to tell this answer and to solve this. So this is basically the question coming from your rigid rotor, actually from your physical spectroscopy. Okay, rigid rotor model actually. So just look up on the question. What is saying there? A quantum mechanical particle of mass m free to rotate on the surface of a sphere of radius r. Okay, so it is defined that this question is talking about our rigid rotor model and the spherical sphere like with the radius of r. Okay. So they have given an energy 10 h cut square divided by mr square, and you need to answer the degeneracy. So how we can answer this type of question? Okay. So basically, you all know this is the solution. Actually, the correct option will be the option C. Okay, so option C means it's 9, not the B, Muhammad. The correct option will be the option C, that is 9. Now, how to approach this kind of questions? Okay, so basically, when you know that is the question is asking from a rigid rotor model, you should know, you must know all the important things related to this rigid rotor model. That is the energy of quantized energy, that is the energy level, quantum level, everything related to that. You need to remember this particular things. Otherwise, you can't solve this question. Okay, this type of questions. So, very important things. The formula you need to remember. Okay. So basically what happened, what is this? That is here, pointer is not working, I think so. Okay, so this one. Okay, basically this capital J, actually the quantized energy of each energy level. Okay, so in rotational spectroscopy, what is this going in its aspect of rigid rotor model? This is nothing but root over J into J plus 1 into H cut. What is H cut? That is H by 2 pi. You all know that H by 2 pi. Okay. So, and you also know that the energy E is given by E equals to J square by 2. That is J means this capital J, this thing. Okay. You also know that. So J squared by 2I and I is the moment of inertia. Now you need to put the value here, J value this one, that is quantum level use here, that is J into J plus 1 into H cut square. If you square this, okay, so you will get this value by 2I. Okay, so this thing, okay. So now instead of I, put the value, this is a spherical sphere, right? You know, so the I will be, the moment of inertia will be mr square, right? So that put the value and equate this with the given energy value. Equate this equation with your given energy value and you will definitely get, solve this and just solve it and you will get J equals to 4. So now you know that J is 4 and you need to find the degeneracy of state. So what is the formula? 2J plus 1, you all know that? Yeah, degeneracy means 2J plus 1. So just put the value here and calculate and you will get, the answer is 9, okay? So basically our correct option is 9, that is option C. Okay? Are you getting my point? Am I clear to everyone? Am I clear, right? Okay, so if I am clear to everyone, I would like to move to our next question. Okay? Yeah, this is our next question. Our next question is the combination of nitrogen and oxygen at 27 degrees Celsius occurs according to this equation is given here, that is 2N2 plus O2 plus 2Na2 and delta H equals to 39.4 kilocalorie. That is delta H formation for this particular reaction. Okay, delta H formation. And what will be the heat of formation at 227 degrees Celsius? Use the relation given Cp equals to, a relation is given there. And you all know that Cp is the molar heat capacity at constant pressure, and the data are provided like this. In a table format, you have given the data of the, that is A value and B value for nitrogen, oxygen and N2O to calculate the Cp value. Okay. So which will be the correct option? Just try by yourself and try to give the answer. Anyone from you would like to try this question? Am I audible, right? Am I clear to everyone? Okay. So try to answer this question first. Anyone from you would like to comment so that it will be visible to me? Okay, Muhammad Kalibullah is option 2. That is 54.42 kilocalorie. Okay, Muhammad, I got your point. Anyone else would like to answer this? Okay, so let's try to solve this type of question. How to solve this type of question? So basically, this question is from your thermochemistry. You all know about thermochemistry. So basically, it is from thermochemistry. So you have been given a particular equation, that is 2N2 plus O2 equals to 2NO2. This thing is here. Yeah, this one. And you have been also given the delta H formation for this particular reaction. Okay, how the 2Na2 actually formation of the delta enthalpy value. And this is given in a particular temperature. You need to remember this, that is 27 degrees Celsius. Okay, and now you have been asked what will the delta H formation of N2O at 227 degrees Celsius. That means 27 degrees Celsius means 300 Kelvin and 227 degrees Celsius means 500 Kelvin. Okay, so you need to answer this question in terms of 500 degree Kelvin. Okay, so how to solve this type of question? So basically, you all know at first you need to consider the Cp value. Because why the Cp value you need to consider? Because you all know this is thermochemistry equation and you need to follow the Kirchhoff's equation. Okay, you all know that Kirchhoff equation, and basically the Kirchhoff equation is follows like that. Okay, basically Kirchhoff equation is going to tell like that, delta H, if it is, you are able to find this, I think. And you know that delta Cp, that is Cp dt, right? So my pen is not working properly, so I would like to just underline this portion. Okay, you all know the formula, actually Cp dt. It is delta H formation, that is difference equals to integration of what? Delta Cp into dt. That is dt, and you need to integrate that part. So you need the Cp part, right? Cp, that is the molar heat capacity at constant pressure. So at first you need to find for the all these three terms. Okay. Okay. So delta Cp means the change of Cp value. Okay. So how need to calculate this? That is product value minus reactant value, right? So how you will do this? This is, yeah, product means 2N is 2N2O and minus N2 minus O2. Okay. So how to calculate? You have been given here the thing, right? The equation. You need to follow this, A plus BT, and you have given all the A value and B value. Okay, all the A value and B value here. Just put this for each and calculate. And one important thing you need to carefully you need to look this. Here is a T term, right? And you also have a 10 to the power minus term here, right? So don't forget to consider this 10 to the power minus 3. If students often do this kind of mistakes in their examination actually. So it will definitely you will get a wrong answer. Okay. So just consider these things and find this value, and yeah, you will get this type of where is the, yeah, you will get this answer, right? and let the T as T. Don't put the value here at first, just remain it as T. Keep it as it is, okay? So now you know the Kirchhoff's equation delta H, and so you have the delta H value for 300 degrees Celsius already, and you need to find the 500 degree, okay? Just instead of Cp, put this value, and T is given like that, and you can now multiply by dt with all things. You can carry this like this and just do the integration part. I'm not showing the integration part here. I hope you all can understand the integration part, that instead of this part, it's the constant term, right? So when dt is here, you will get a T term, that is temperature, and here is already a T is present, right? Already a T is present here. So you will get T square by 2 like this. T and T square like by 2. And putting the value, limit value, the upper limit and lower limit, that is 500 and 300 here and also here. Okay. Thus you will get your delta H formation at 500 Kelvin, right? Got my point? Okay, so now you need to remember you are finding this delta H value, this formation value for the total reaction, right? So that when it is you are calculating for the total reaction, then you also considered already this stoichiometry, this two term, right? This stoichiometry. But you need to find only the N2O value for delta H formation for N2O. That's one molecule. Just divide by 2. Just don't forget these things actually. Where is my pointer? Sorry, my pointer is okay. This one. Okay, so you will get that, just divide by 2 and you will get 19.51 kilocalorie. And this is in the option, I think, option number 1, A. So the correct option will be option 1. No, Kalibullah, Muhammad Kalibullah, it's not option 2. It's the correct option is option 1. Okay. So I think I'm clear to everyone, right? So let's move to our next question. Okay, so the question number 3 is calculate the rate of the reaction, frequency factor and the rate constant at 700 degree Kelvin. 700 degree Kelvin, okay, you have been given the Kelvin 700, not the degree Celsius. And 1 atm for the decomposition of HI if its collision diameter is assumed to 0.35 nanometer. The activation energy is 185 kilojoule mole inverse, and the decomposition is given of HI, that is occurs as 2HI equals to H2 plus I2. So you need to find the rate of the equation. Basically, the question in the question actually given one thing. Here actually asked the 3 things actually: the reaction rate, the frequency factor, that is the pre-exponential factor, and also the rate constant. But you haven't given in the option only the rate. So what you need to do, you have to find all the things and they are maybe related to each other. That's why you will get the rate at last. And so the option is given here. Okay. So try to find this. This is a pretty simple question actually. This is from collision theory actually. Collision theory is another important topic that is mainly from your physical chemistry. Anyone would like to answer this question? Akash Pansuriya, 2 is correct. For this question, Akash, the answer 2 for this 3 question, okay? Number 3 question you are answering. Okay, so your answer is 2. Anyone? Okay. Anyone from you would like to answer this question or try to solve? Just try. You need to do one thing actually, because the physical chemistry is something about being knowledgeable, being actually being you need to clear your concept from each and every topic that coming from the physical chemistry or everything. But actually you need to keep practicing more. Otherwise you can't solve the numerical part, and there are a lot of numerical parts actually coming in the question paper. So you have to keep practice, otherwise this type of question will be difficult for you. Okay, so let's try to solve this type of question. How to solve this? This is basically from your collision theory, okay? So, yeah. We have given here the decomposition is like of HI, that is the follows this equation, 2HI equals to H2 plus I2. Okay, so this just look upon our this equation. Okay, So this is what kind of equation? From this we can write the rate of the reaction, rate reaction actually. That is acidity minus acidity. You know also how to express the rate of reaction, and this is basically K into C square. K is the rate constant and C in mole per liter. That is concentration of your reactant, and it is secondary. That is the kinetic order is second to the kinetic order of the reaction. That is secondary kinetic order reaction. This follows. Why this? Because in the reactant you can see these things. That is the two term. That is the stoichiometry tells us about the secondary kinetic order following. So now you need to know if you know that is the collision theory equation, you must remember this equation for rate equation, actually rate constant. You must remember this. You can't do anything about this, but the collision theory is very, very important, and one or two question every year it comes from that part, and you need to actually remember this particular, this formula for the rate constant in terms of collision theory. And what is the rate constant? K. The formula is root 2 pi into n by 10 cube. N means what? The n defines the Avogadro's number. Okay. And then the sigma squared, that is sigma is the collision diameter that is given in your equation also. It's represented by sigma. And then the root over 830 by pi n, this is the C value, velocity value, average, and E into e to the power minus E by RT. That is, you also know this term, exponential term, and this activation energy is included here. Okay. So liter mole inverse second wave, this is the unit. So if you know this, if you remember this particular equation, then just put the value here. N is Avogadro number, that is 6.023 10 to the 23. This values, everything you need to just put this here, the collision diameter, everything, and calculate, and you will get the value like this. Yeah, like this. You will get this kind of value. So what you do, so you have got already the rate constant value. Now you need to find the pre-exponential factor or the frequency factor. You have been asked in the question. So what is this? Compare with the Arrhenius equation. Actually, you also know the Arrhenius equation for the reaction rate, right? So K equals to A into e to the power minus E by RT, right? You all know these things. It is a very simple. You all read this in your 11-12 basic standard. Okay, so just compare these two equations. And here just look up on the equation. This e to the power minus E by RT is very, very similar with this E term, right? If you don't calculate first this, you can easily compare with this, and you have the constant term before this. This is your pre-exponential factor term. That is A here. Okay, this is A term. That is, you also got your frequency factor. And now you need to find the rate of the equation, that is K into C square. You already know this. So what is C? Concentration. How we put this value? We all know the PV equals to nRT, right? PV for ideal gas, PV equals to NR. Sorry, just ignore my typing style, but I would like to make you understand these things. PV equals to nRT, right? So when you divide the N value, N by V actually, volume, mole number divided by V actually, what we get? That is P by RT, right? So this is nothing but our C. N by V represent the concentration C, okay? So just we have done this, and value, put the value here. P is 1 bar, R is also you know, and given also in the equation paper. T is the temperature, 700 Kelvin. It is Kelvin, okay? So just calculate it and you will get your rate, okay? So that's how this type of question will be solved. And look, this is a pretty simple. Actually, you need to remember just the equations and just putting the value. You need to calculate this. This is nothing else actually. You also have the calculator that is in your digital calculator, right? You also can use in this examination. The CSIR also provides this during these days. So you can also use that part to calculate this type of things, okay? So the correct option will be 6.34 in 10 to the power minus 7. That is, yeah, this option 2. Option 2 will be the correct option. Anyone from you gave this action? Akash, yeah, Akash, your answer is correct. 2 is the correct option. Are you getting my point? Akash, 3 is Oh yes, sorry, Akash. This is not 2. Sorry, I extremely sorry. It is 3. Yeah, 10 to the minus 7, right? It's not 5. Yeah, this type of mistake mainly happened from the student side actually. Just before answering the question, just look carefully the options and then answer. Okay, the option 3 will be the correct option. Yeah. So if you, acha, option 3, yeah. शक्तिवेल ऑप्शन 3 या शक्तिवेल तुमने भी सही आंसर दिया मतलब एकदम ऑप्शन 3 इज द करेक्ट ऑप्शन सो लेट्स मूव टू आवर फोर्थ क्वेश्चन या दिस इज ऑन योर रिएक्शन मैकेनिज्म in your organic part, right? The major product of A and B in the following reaction sequence are, and you need to find the major product in this particular reaction. So try by yourself and then answer which is the correct option. Shaktivel, Tamil Nadu. Okay, you are from Tamil Nadu. Okay. Okay, fine, Shaktivel. Anyone would like to answer this question? What will be the correct option? Okay. Zoom. Is the screen visible to everyone? A or C? Within A or C? Muhammad Kalibullah, you have answered the option A or C. Yes. Okay, so you have answered the option A or C. So which one will be the correct option? Let's try to find this question. How to solve this kind? This is basically from your reaction mechanism. You all know that, and you need to answer correctly this question. So how to approach? So see, you have given this particular ester, right? It's a ester molecule. It's ester molecule. So when we are using this kinds of thing here, that's NaOH, in presence of NaOH, what is happening? Ester has very, very acidic hydrogen at this here, 2 acidic hydrogen here present, right? Here. So when NaOH is present there, so instead in presence of this base, actually what is going to happen? Base abstraction at first happen. That is a negative charge is coming over here like this. Yeah, negative sign will come, negative sign will come over like this, and that will what will do, and that is negative charge will go over it and rotate with the carbonyl carbon. Okay, and again it will come back. Yeah, like this. Again it will come back, and the double bond now will the pi electron of this will act as the nucleophile. Okay, so now it will attack backside attack to this molecule. You also have this in this question, the particular molecule is the tertiary halide, tertiary bromide actually, right? So what is going to happen? So it's not tertiary, it's a secondary actually. Oh, so backside attack will be happen here. Okay, so this is happening here, and we will get this particular type of product. Okay, Br will be leave from this compound, and we will get this particular product. Okay, so yeah, this is our A product. Now you need to find the B product. That is on this. In the question is given that there is tertiary butanitride, butyl nitride is given. NaOH also given, H3O plus and ZnHCl also given. So what is going to happen? Let's see. At first, what is going to happen? Again, it's an ester. So obviously, in presence of NaOH, in presence of base, that first the base abstraction will happen. That is, as the proton, as the releasable hydrogen will release from the molecule, and a negative charge will come over there here. Okay, you also can see this negative charge, and now it's going to happen like this negative charge will attack as nucleophile to the nitrogen atom of the nitrite. Okay, like this. And thus the bond rotate, and you will get this product. And eventually you also know that the O minus also will again try to make the form with NO, and so it will rotate, and you will get the tertiary butyl oxide as the leaving group leave from the molecule, and you will get the product like this. at first. At first you will get this. Okay. So now what is going to happen? Again, the tertiary butoxide is again will act as a very good nucleophile because O minus oxide ion. This is a very, very good nucleophile and it will attack to electropositive center, that is carbon atom here. What is the electropositive center here? The carbonyl carbon. It will readily, the tertiary butoxide will act or attack on this particular carbon atom because it is a very, very electropositive. So what is going to happen? That bond again will break and again will make, and that's thus. And this way here the double bond comes. Yeah. And this bond will be rupture here. This bond will going to break here. And thus we will get a product like this and also like this. And now use ZnCl, that is HCl in the, you have given in the question. So just reduction will be occurs. So NO will be reduced to NH2, amine. So you will be, now you will have the product this, the C, okay, this product. So you have the A product this one and the B product this one. The C, option C will be our correct option. Are you getting my point? All clear, PN. It's visible, ma'am. Thank you, PN. I don't know your full name, so I am calling you by PN. Okay, so it's visible, right? And you are getting my point. Okay? Okay, fine, Akash. Okay, fine, Akash. You also got my point. So this was our fourth question, and it is on it was on our reaction mechanism and how it was. You need to follow this particular trick. You need to how you can solve this particular question. So let's move to our next question. Yeah. It's another question on organic. The fifth question, the mechanism and the product formed in the following reaction respectively are. So basically you have been given this equation, this reaction actually, and this type of molecule, all the three cyclohexane ring are attached with each other, and in between, in the center, you have above the bond a bromine atom, and below that bond actually hydrogen is attached there. And it is like this. The stereochemistry structure of this is like this. And you have given water in the molecule in this particular reaction. And what is going to happen? You need to answer, which is the correct option. Anyone would like to answer this? Second step is difficult in the Muhammad Kariullah. In the previous question, right? Yeah, Muhammad, this is on the previous question was on our reaction mechanism, right? So you need to actually consider each and every step. You need to understand every step, and sometimes it will be difficult, sometimes it will be easy for you, but you can't skip any step. You can memorize any step. You have to have the clear concept about each and every step, sir. Which is nucleophile, which is acting like that, how the backside attack is it's doing there, how the and why it is occurring, when the acidable hydrogen will move from our reactant, or everything. You need to understand each and every steps concepts. Okay, otherwise you can't solve this type of question. So we have our option. So Rajrupa also comment, very good detailed explanation, ma'am. Thank you, Rajrupa, for your valuable comment. Okay, so you all are enjoying this session. That is very that becomes a very, very good thing. And Akash Punya also answered the B. Option B is the correct option. Mohammed says SN2 is impossible because of steric hindrance, and SN1 is favored because of stable carbocation and racemization occurs in the product. Yes, Mohammed, you have answered this question. Okay, anyone from you would like to answer? Mohammed also answered this question. So yeah, let's start to solving this question. How to solve this kind of question? Yes, basically this is, you can see that it's a tertiary alkyl halide, right? So it's absolutely right, Mohammed. When you try to do SN2 attack, so it is very, very difficult because backside is already hindrant. It's very, very steric repulsion happening there. So no other option. Already it is tertiary halide, and you know that the readily it will undergo the SN1 solveresis, right? SN1 solveresis. So at first, what is going to happen? Yes, if we just draw this in terms of the chair form, the cyclohexane in terms of the chair form. Okay. Uh, 1 minute. Okay. Now it's visible, right? Okay. So this is our structure basically. Here above the plane, the beer is here. Okay. So the beer will eventually leave from this molecule because it undergoes section 1 solubilysis. So we will get this kind of carbocation. And the carbocation will come over the bridgehead position. Like, is this bridgehead position? So and now you know then the water will act as a nucleophile and in SN1 solubilysis, everything it is, you know, all this, it will undergo a racemization. That means 50% of R and 50% of S molecule we will get. So basically we will get the racemized product. So the particularly the stereochemistry is not defined here in the product. Okay. So this how we have written here. So basically, yeah, this answer is the B option and this is the B option, SN1. Okay. Here actually in the question actually there was a printing mistake and they have given a above the plain like sign, but it was not going to happen. Actually, it was a printing mistake. There is actually they would like to say this type of thing, that is this kind of thing. Okay, also here represented here. So this is the option B, SN1, but not the SN2. Okay, not the SN2. So the option C will be cancelled out and all other option will be cancelled out. Only the SN1, that is option B. Okay, so now you get my point. Am I clear to everyone? Very simple, SN1 because H2S. Very good, Akash, you also got my point. Fine. So let's move to our next question. Okay, so let's before moving to our next question, I would like to say one thing, that is from the 4th March of 2022, new batch of CSIR net actually preparation we are going to start. So what we will provide here, the exam focused daily classes, printed hard copy study materials, unlimited expert assistance and doubt solving via chat, class tests, monthly practice exams, all India level test series, and video backups of all classes and much more. Okay, you can also contact with the toll free number here and also contact with our email ID that is given here, and also can contact with the stores where you will be provided all the study materials and the books relevant to this course. Okay, so you can join these things. So it will going to start from the 4th March. Okay. Okay. So next question. Yeah, this is from inorganic part. Which one of the following has the regular tetrahedral structure? You need to answer this. It's a pretty simple question. Which one is the regular tetrahedral structure? Anyone would like to answer this question? Please type your answer in the comment box. It's a very simple question. It's on your, actually it is coming from your bonding chapter, molecular bonding. And you need to answer this question with using your VSEPR theory or VBT. Okay. Mohammad Kalibullah, XCF4 square planar, SP4 distorted tetrahedral. Okay. He has given his answer. Okay. Anyone else? Anyone would like to answer this question? You need to consider this type of question every year. This structure related question they would like to prefer. Actually, they prefer to give this type of question in the examination actually. And so many questions are there. 4 to 5 questions related to your structure actually. Okay, every year. Orghodip Dash told this answer, the C, option C. Okay, this BF4 minus. Okay. Okay, so Mohammed, you have again told that BF4 minus tetrahedral and the 4th one is square planar. Okay, your answer. Okay, so let's try to solve this question. How to approach this kinds of particular problem. So you have given this XCF4, this molecules actually. Yeah, this molecules SP4, BF4 minus, and also NiCN whole 4 2 minus. Okay, so just let's start with one by one. Okay, so at first from the XCF4, what is the structure? Xenon has, in terms of VSEPR, we can predict this. Xenon has 8 electrons in the center actually. So and all the 4 fluorine electron is attached to this. Fluoride electron is attached to this. So you have now 4 bond pair and the remaining 2, that is 4 electron, that is 2 lone pair, right? So you have 4 bond pair and 2 lone pair, okay? So this is nothing but a square planar structure for A, okay? Yeah, like this, square planar structure. Yeah, got it? And for the SF4, it is also a tetrahedral structure but distorted, okay, because the sulfur has a central, there's a 6 electrons and there are 4, actually the 4 fluorine going to attach with this, so 4 bond pair and 1 lone pair is there, so it is not regular tetrahedral, it is a distorted tetrahedral. And again for nickel, this nickel tetracyanide, okay, this type of molecule, actually this is also square planar, and you know that this type of molecule actually cannot be predicted from the VSE pair, and we need to help of VBT, valence bond theory, okay? So this is another square planar complex. And now you have only remaining the BF4 minus, and obviously this is the 4 fluoride atom, and also minus charge, consider that above the total structure, the boron had already 3 and it is of total 4. So 4 bond pair and 0 lone pair, right? So it is the regular tetrahedral structure. It is going to show the regular tetrahedral. So only the correct option is option C, and that is BF4 minus, right? Yes, this option is our correct option, option C. Okay, are you getting my point? Okay, Muhammad Alibullah, you have solved already the questions, right? Okay, bond pair and lone pair. Okay, it's fine. Distorted tetrahedral. Yes, Muhammad, I got your point and you have solved. It's pretty nice, I think so. Okay, so everyone, everything is clear to all of you, okay? Okay, so let's move to our next question. That is question number 7. Yeah, this is another important topic, that is a solubility product. It's another important topic for you all, actually. So every year, one or two question that is coming from the KSP value or related to this, that is solubility product. So you need to understand this type of question, how to solve this question, and what are the KSP value, and what is the basically formula used for this particular things. You need to know this, okay? So the question is the molar solubility in mole per liter of a sparingly soluble salt. What is the salt? MX4, okay, is S. You have been given the solubility is S. And the corresponding solubility product is KSP. So S is given in terms of KSP and S by the relation. And you need to find actually the S in terms of KSP value. So what is the correct option among these all? You need to find. So anyone would like to answer this? Akash, okay, you have shown the thumbs up. That is that means that you are understanding everything. Okay, okay, fine, Akash. Anyone would like to answer this question? It's a very important question, actually. This type of question, you every year 1 or 2 question coming from for you in your CSIR, actually, in form of the solubility product, actually. Okay. So how to approach this kind of molecules, this kind of question? Okay, Orgodeep. Okay, Orgodeep has also answered this question, option D. That is KSP by 256 and 1 by 5 its power. Okay. Okay, fine. Anyone else would like to answer this question? Okay, so let's try to solve this question. How to solve this question? Okay. Okay, so yeah, this is our equation. That is MX4. That is our solid. That is sparingly soluble salt we have taken in, or given in the question, and how it is dissociated in the solution phase. Okay. That is, M is metal center and X is the ligand attached to that. So we will get the M4 plus cation. Why M4 plus? Because X4 is given here. 4 ligand is attached to it. So we will get we know how the charge is taken. You also know that. You all know that. That is M4 plus in the aqueous solution. And you will get the X minus, and you have the 4X. So it will be 4X minus. Okay. So now in the equilibrium form, what will be the solubility in the equilibrium term? So basically for M, we will get the S. That is the solubility is given in your question, that is S. And for the M value, M plus, M4 plus, And for X minus, there are 4X minus, right? So we will give, it will give the 4S. You know all these things, right? How to write these things, how to, actually in terms of kinetics, actually how to write this type of things actually. So S and 4S, right? So now you know what is the solubility product, how to calculate this. You have already the S value, so you need to just multiply those things. Ksp equals to the multiplication or the product of both the anion and cation you have. Okay, so just S into 4S. And just you need to remember one thing here, that is in this KSP value, students always do mistake in this part. That is when you have the stoichiometry, right? You need to consider the stoichiometry in your solution, okay? So you are using this 4S, right? So it will be going to write, it will be, we will write like this. The power will come a 4, okay? So S plus 4S square, okay? Like this. If you have this 4, instead of 4, there is 5 or 6, here the change is the power, okay? So just calculate this. This is not 5, this is S actually. Okay, so just calculate this and you will have 256 S to the power 5. So just you need to find the S value. Just root over this, fifth root, right? This is S equals to fifth root of KSP by 256. Just equate this and solve this. And you will have this one. Okay, so our correct option is option D. And you will get here this one, option D, right? This is the correct option. So it is a pretty simple question, how to solve this type of question. I think you all got my point, right? Am I clear to everyone? If I am clear, you got my point, please answer or comment in the comment box just to confirm me. Okay? It's a pretty simple question. This is from your actually solubility product. And basically it comes from solubility product means in sometimes from physical chemistry and sometimes maximum times is from the inorganic part also. This comes actually, and you need to follow basic the kinetic theory, actually kinetics, how to solve this, how to and you need to remember the formula and the techniques, how you can write these things like AS or 4AS or power, how you need to write these things, and just you can calculate these things. Okay, so it's clear to everyone, right? Okay. Okay, so let's move to our next question. Yeah, this is our next question. Among the following molecules, the shortest bond length is to be found in. Which of the following option is correct? Okay, the shortest bond length. You need to find the shortest bond length for this particular molecules. That is carbon, nitrogen, oxygen, and fluorine. Which has the shortest bond length? It's another inorganic question that is mainly related to your molecular orbital theory. Okay, bonding part, molecular orbital theory. You can, if you know the concepts, how to fill the electronic configuration, how to fill the electrons in the, how to write the electronic configuration for this particular, for the every elements actually. So then you can solve this kind of question. Okay. So Argudeep has answered the option B, that is nitrogen, right? Argudeep answered there's a shortest bond length will be for nitrogen, option B. Mohammad Kalibullah told the bond order increases, bond length decreases, nitrogen bond order is 3, so bond length is very low. Okay. Let's see what is going to happen. So the answers are coming like B, now for the nitrogen. Is it correct? Okay. So let's see how to solve this question. What is the correct option? The correct option is option B. That is nitrogen. Okay. Yeah. You all are right. Nitrogen is the correct option. So how? Just see how to approach this kind of particular question. You need to know to solve this kind of question, to answer this kind of question, how to represent the electronic configuration in terms of MOT, molecular orbital theory. So you need all to know, this is a few actually examples I have given here to show you. Actually, basically the sigma, you need to know these things. For nitrogen, basically, if we can see this, yeah, this is nitrogen. 14 electrons, right? So sigma 1s2, you all know that the orbitals, how to read, I had to write this, okay? So sigma 1s2, sigma star 1s2, then, sorry, this is sigma 1s2, sigma star 1s2, then the sigma 2s star 2s2 and the sigma star 2s2, then the pi 2py, it's also going to, 2 electrons will fill there, and also pi 2pz, and then the 2p sigma 2, that is sigma 2p. It's 2 again. So we will have, if we calculate these things, you will get here the 8 bonding electrons minus, how to find the bond order? That is number of bonding electrons minus number of anti-bonding electrons divided by 2. So 8 minus 4, 4 basically divided by 2. This is for carbon. No, sorry. We are going for nitrogen, right? So this is nitrogen. Yeah. We get the, if you calculate this, the 10 bonding here and the 10 minus 4 divided by 2. And you will get what? 10 minus 4 divided by 2, you will get 3. Okay. Okay. Again, you can also follow this simple trick. Just put the electrons, total electrons for carbon, it will be 12. For oxygen, it will be 16. For fluorine, it will be 18, right? So if you put all these things, you will get the number of bonding and anti-bonding. For nitrogen, thus you will get, and for carbon, you will get the 8 bonding electrons minus 4 bonding anti-bonding electron divided by 2. And for oxygen, you will get, for oxygen, you will get the 10 bonding electron minus 6 anti-bonding electrons divided by 2, and you will get 2. And for fluorine, you will get the 10 bonding electrons. The 10 bonding electrons minus the 8 anti-bonding electrons divided by 2. Okay, the bond order will be lowest for fluorine. Okay, are you getting my point? Actually, the fluorine will be not like that. For this, actually, the electronic configuration is slightly changed. The sigma 2px and the pi 2py star, this is also changed. Their change. This is because their symmetry factor, right? You all know these things, right? So basically, not fluorine. You can consider the nitrogen here. Actually, the correct option will be the nitrogen, the option B. The fluorine will be different for this question. Actually, the sigma actually 2pz. 2px will come first and then the pi orbital. Okay. Yeah. Bond length is very low for nitrogen. Bond order increases, bond length decreases. Yes, it's a pretty nice. It's a pretty nice concept actually. So you will have the nitrogen, option B is the correct option. Okay. So you all got this point, and I know this is a pretty simple question and the pretty simple concept according to bond order. You all know this. Okay. So let's move to our next question. Okay, so this question is again from your term symbol. That is from your atomic structure. The question is the ground state term symbol for high spin D5S1 and D5 configuration respectively are. So you have been given the electronic configuration D5S1 and D5 configurations. So what are the particularly the term symbol for this? What will be? Anyone would like to answer this? Yeah, it's a pretty simple concept of atomic structure. It's a very, very important term symbol every year. 2 or 3 term symbols equations actually are coming from this from the CSIR net exam. You will get 2 to 3 questions from the term symbol actually in the examination. Again, for the C section, some or somewhat in the B section also. Okay. So what will be this? Orgudeep, C, option C. That is 7s and 6s. Okay. Okay, Argodeep, you have answered. And anyone would like to answer this question? Okay. Yeah. So let's try to solve this question. How to solve this question? Okay. So you have D5S1 and another thing is D5 configuration, right? So let's start with D5S1 configuration. The electron is, and this is an high spin case, so we will have all the 6 electrons unpaired. Unpaired electrons are 6 because all the D5, if you see this d orbital, yeah, basically like this, you will have all the 6 unpaired electrons. So how we will represent our term symbol? This is 2s plus 1. The representation is going to be like that. 2s plus 1 is the multiplicity. Then we will write the L value, and then again in the down part we will write here the J, that is the degeneracy. Thus you don't have to calculate J here because in the option it is not given here. You need to consider only these things. Okay, yeah, only these things. So for this is the number of unpaired electron, the formula you need to know, that is n by 2. The S value equals to number of unpaired electron by 2, n by 2. Okay, so 6 by 2 you will get 3. Now you need to find the multiplicity, the 2s plus 1 term. So you will get 7. And now you need to find this L value, right? So how to find? Just feel like this, and you all know the value is going to be like this: 0, -1, -2, and the +1, +2, like this here. I have also underlined here, right? You know these things. You have to just you need to calculate these things. How to how to calculate this thing? Just number of electrons into the value, okay, and go and just add these things. So 1 into 2 plus 1 into +1, just 1 into 0, then 1 into -1 and 1 into -2, and also +1 into 0. Just all the values, add this and you will get the value. You will get here 0. So now you know the L value if comes 0, that means that represents the S, okay? So you are going to write like this. Now you will have 7s value. That's the multiplicity is 7s. This is term symbol is actually 7s. Similarly, you can also find for the D5 electronic configuration. Again, you have unpaired electrons, 5 unpaired electrons. So the S value is 5 by 2. And again, the similar way you can find these things and you will get the 6s value. Okay, 6s, the multiplicity. It's a pretty question, simple question, and you all have this answer. The option C is the correct option, right? Orgudeep, you have given the correct answer. Mohammed, Kalibullah, number of unpaired electron plus 1. So 6 plus 1 is 7. Okay, Mohammed, you have solved this question and I can see, and it's the absolute right. So C is the correct answer, right? Yeah, it's very, very accurate actually, and the concept is pretty simple. And it's a very important topic actually, the atomic structure, and the term symbol every year comes 2 or 3 question in the question. Okay. Okay, so let's move to our last question, and this is another from our organic part and basically from our reaction mechanism of intermediate terms. Okay, so in the reaction, in this type of reaction, what is going to happen? You need to answer the correct option. Which is the correct option? Anyone would like to answer this question among you all? This is a pretty simple question actually from reaction mechanism, but just you need to have a clear conception about a particular thing, then definitely you will answer this type of question. So we don't have much time, so I need to solve this question for you all. It's an important type of concept actually. I will going to discuss here. Okay, so how to solve this type of question? Basically, just see on the molecule, look up on the molecule. Here all the double bonds are in the cis form, and basically this is will be going through the intramolecular in-type reaction. Intramolecular in-type reaction, and when you undergo some type of this type of process, actually intermolecular, okay, intramolecular actually. So what is going to happen? This is going to happen, that is the attack or leaving of the groups or attachment, everything will be going from any one's phase, that is above the molecule, either this phase above the molecule or down the phase, down the molecule. Any one phase will be involved in this particular question. So basically you would going to like this kind of cis type of product actually. So how you will get this? In presence of heat, actually, basically the CH3 part in the term, the CH molecule at first break down, and a double bond will come here, and eventually this double bond will break and make a negative charge over here, this carbon, over this carbon, and negative charge will come, and this negative charge will attack to this carbon actually, because it's a C double bond C, and actually it is an electropositive center. Okay, so then what is going to happen? This double bond again as a negative charge come to over this carbon. So we have now here the CH2 minus, right? And this minus charge actually attack this carbon. So we will have a 5-membered ring, not the 6-membered ring. Don't be confused about these things. We will form here a 5-membered ring. Okay, students, maximum students actually do this thing, just join this bond and they will get a 6-membered ring, but it's not going to happen here. Actually, this is an intramolecular diene, actually intramolecular in type of reaction. So this type of mechanism is followed actually. So this bond rupture actually first step going, then this double bond will make a negative charge and that will attack to this particular carbon and it will going to show the negative charge over the carbon atom. So we will get a 5-membered ring and obviously again this minus charge again will obstruct an hydrogen atom. So he will getting the CH3, okay, here, right? So we will get like this type of molecule, either this or this, both are same structure actually. Yeah, this is our molecule we will get. Okay, so just look upon the stereochemistry of this part. Both are from the same side attack, right? The same phase actually attack, either on the above the phase or the below the phase actually, any one of this. So you need to consider that those both the actually the structure actually attachment, the molecule will be, the stereochemistry will be like cis or psi or phase, that is the cis molecule we will get, not the trans molecule. So we will getting the here, that is the cis methyl 2-vinyl cyclopentane. Okay, this is our structure basically, and this is the 9A option. Just look upon our structures, that is the option A is the correct option, not the B, because the stereochemistry is different here. This is the same phase like structure, intramolecular and in-type reaction, so it's not going to happen, and obviously not the 6-membered ring and not this type of molecule actually. So only the option A is the correct option. So am I clear to everyone? A will be the correct option. Bhavani, yes Bhavani, A is the correct option. You are absolutely right. Organic chemistry, pericyclic reaction, in reaction. So A is the answer. Yes, Mohammed, it's A answer will be the correct option. Vandana Kar, Nitin Anil answered the D. I think you have answered for this question and it's D, it's not D. That is I also told just few minutes ago. Just the few, students also make this type of mistake. They will see the structure and they just make the bond there and they will get the 6-membered ring. That is not going to happen here. Okay. Okay, so I think you all got my point, and today's class, today's 10 questions also was clear to everyone. Okay, so hope you all enjoyed this session also. That's all the question, and just keep preparing like this. Also try to cover all the topics I have also mentioned in today's live session. Also you can see also those in the recording video also, the important topics. You need to prepare these things, and all the best everyone. So thank you very much.